sections so far after 3 days. They got LLMOps. The LLMOps, technically, they are the entire process, the entire protocol. If when we implement LLM in industrial, generally we are talking about Gen AI, and looks like everyone think like we have to expert about AI or yeah, kind of. But in LLM labs, we have a big picture. We need more person than that. The LLM labs, technically, they are develop, they including the deployment, monitoring, and maintenance of LLM. So in order to do so, we need to collaborate of many people, including a data scientist, a DevOps engineers, and IT professional. Many people join in this program. And in LLMOps, they involve many steps, such as how to ingest the data. There are many phone calls to us, so we have to, so which means that the data we ingest to us quite frequently. How to label the data, how to do prompt engineering, and how to do fine-tuning. And after fine-tuning, how to monitor the model, how to make sure that the model will work in practice, or we have to adjust something in practice. And also, we need to implement how to implement the search engine, how to implement the knowledge graph. The search engine and knowledge graph by itself, there are many algorithms. So in practice, we have to select good algorithm. So it requires many experiment. And even though after experiment, the algorithm is good, but the latency is too high, then we also have to adapt to change the experiment. Then after experiment, we have to find we find a really good approach that I can put that approach to IT professional, such as Jinman, and then Jinman will start implement and scale in the large scale domain. Also, because we work with a big data, so we also need a person to do the database management, storing the vector, make the vector calculation, indexing data. And after we finish all of that, we also need to evaluate our system, including measuring the latencies, measuring model performances, measuring any technical error that can happen in our system. And if possible, in the good case, we can build a pipeline for automate process, including automate data ingestion, automate data labeling, maybe automate prompt engineering or automate fine-tuning technique. That is a big picture in a good case. So in short, in the diagram, we can have a diagram like this. This is the example of development workflow of LLM. We can find a foundation models, LLMs such as ChatGPT or Claude or Gemini. Then we can do a prompt engineering. The prompt engineering sometimes it takes lots of time to evaluate. We have to select a good prompt engineering technique such as React or prompt chaining or a few shot, one shot. And after that, we evaluate the result. And after evaluate the result, we can see that looks like we need to improve a bit about the model. And if it say, okay, we need to improve, then we have to ask, where is this error come from? Maybe the error come from the data. Maybe it's come from the search engine. Maybe my graph is too big to calculation. So at that time, we have to reevaluate the process. And sometimes we have to consider, should we fine-tune the model? Maybe yes. If yes, then we start pre-process fine-tune the model, evaluate the result, checking if there are anything should to be improved. And if we think anything is perfect, then we go to the deploy production. And even though we deploy to production, in reality itself also have some challenge we have to face, such as the data is wrong, run incorrectly, too high latencies, the customer is not satisfied with the answers. Then we have to do something like A/B testing, canary system, reevaluate the result again, and improvement. So this is the entire picture of LLMOps. It's quite tired and
in our discussion in the Amazon,
yeah.
They said alpha testing and beta testing.
A/B test, yeah.
I don't. Yeah, I thought it's different in the A/B. What do you mean by A/B test here?
The A/B test is kind of selection, such that we have fine-tune the model and non-fine-tune the model. We will set and select pick one or two.
We run concurrently, and then we check the outputs, and then we choose A or B.
Yeah.
Right. They said that.
So canary is kind of like sub-server because we cannot test on a real server. It's quite risky. So we have kind of sub-server to test.
Alpha test and beta test means any specific in AI?
It sounds like when I work with the AI, I develop many models. But in practice, I don't know which model is good. So I have to perform the A/B test to test. This model around 90%. This model is just 89%, but it's quite balancing or faster. So that is the A/B test.
알파 베타는 약간 좀 출시랑 이게
그렇죠.
개념이고 AB는 새로 모델 만들었는데 이전 모델을 테스트해보자.
비교하는 거예요.
네, 보통
저도 그렇게 이해했는데.
Okay, so this is the general diagram. So let's go to the detail. The LLM works basically is contain four main modules. The first module is we have to collect the data and prepare the data. This process including collect the data, pre-process the data, and formatting the data. We collect the data maybe from the phone call, or from user chatting, or from other departments sending email to each other. We pre-process the data. Sometimes the data contain the noisy information, or the speech-to-text API itself has some error, and we have to correct that error. And we have to format the data if we need fine-tuning, or at least format the data for RAG in good form. And then the second module is develop a LLM model. In the development LLM model, it maybe we have to fine-tune the model, or we just simply apply RAG, or we have to combine both of that. And also in model development, we can do the prompt engineering. We have to apply the chain prompt similar to Kenya's GPT, a chain prompt and evaluation. And in the model development, because we also work with RAG, so we also need to find the search engine, modify a good search engine, and also the knowledge graph if we need. Then the third module is deploy the model in practice. Technically, in traditional deep learning, we need to set up a infrastructure. We have to set up the amount of GPU, the memory of GPUs, the CPUs, the capacity of CPUs. But if the client already provide the API and run on their cloud, then maybe we don't need to worry about that. All we need is we checking about the latency and the efficiency of running the API. Then the fourth module is we have to manage model. You can imagine that in this month you fine tune the model. The next month maybe Jinman Sam think, oh, we can fine tune better. And the next month me think that, oh, we can fine tune better. Then we have 3 versions. But then when we come to Ichongho Samonim, Ichongho say that Jinman's version is better. So at that time we have to have the method to monitor the process when we select this model, when we select that model. And also we have to monitor the model performance. When we deploy to the company, sometimes the counselor say that the model performance start getting bad and bad every day. Then we must have some like kind of log file or something, or checking data to see where is the error come from. Then maybe we should fine tune the model, or reapply the RAG, or check the search engine. We might have to retrain the model if we need. And one thing is that we have to make sure the model is secure. No one knows this model, and it cannot be leaking to the public. So let's go to the first module, is data collection and preparation. So currently, the raw data might come from a speech-to-text model, cooking the client call to us. And if you are watching a YouTube clip and you click on a subtitle, sometimes they show some text, they convert speech to text. But if you don't listen, you just read the title subtitle, sometimes you see, it looks like it's not making sense. Like the sentence is so weird and noisy. So that kind of noisy will happen in our project. The speech to text, the text before the quality is quite bad. No comma, no period. Sometimes I say one word, but the speech to text appear on another word. So this may make everything noisy. In this step, we have to format the data to grammatically correct. Like Ichung Ho Samonim said, what is the algorithm in this way? So this is the algorithm. We have to find the method to format the data to grammatically correct. Then we start doing RG later. We can do data cleansing or data chunking because when the client communicate with our company, sometimes they talk for 5 minutes, they talk for 10 minutes, they can talk with various of problem. Maybe the first 2 minutes is about the phone, the next 2 minutes is about television, another next 2 minutes is about something else. So we have to split the data, chunk the data into the specific topic instead of put everything as a whole. It's not good. So that is thing called data cleansing or data chunking. And if we do the fine tuning, of course, we have to do the data labeling. And like I say on the fine tuning, we have to balance between tasks, such as a summarization or suggestion or other tasks. Make sure that the data amount on each task are quite equal. Don't make too much bias. If the many data is about summarization, but just a few data is about suggestion, the model will good at summarize, but really bad on suggestion. It is not good. So in this step, we have to do the correct bias. And like I mentioned, we also have to implement the search engine or the knowledge graph. But even though search engine or knowledge graph, we need to add many related information as possible. This will help us for retrieval. This adding we can call as that metadata enrichment. Is that, for example, if the we chunk the long text into a really small subtext, we can add one metadata is the position of that chunk on the big text, or we can add generate relevant keyword or attribute, because if we use keyword based in search engine, then if we have more relevant keyword, more various writing style for one specific problem, then the keyword base will be helpful. Or we can add some attributes about our data. We can add something like analyze the sentiment, whether the client is happy about the solution or feeling negative about our solution. We can add some entities, the thing that the client mentioned, such as the product name, product capacity, the syntax that can happen on the information, such as noun, verb, object, something, and entity sentiment. You can see that in one long conversation, sometimes client is happy, sometimes client is sad. So we can identify which sentence is happy, which sentence is sad. And finally, for those metadata enrichment, we can also implement the knowledge graph. Like I already explained, the knowledge graph can be useful in the suggestion. It's can useful, or we can combine with RAG and search engine. Now let's go to the second module, is model development. In the model development, we will implement a search engine. And like we already said before, we can combine a hybrid solution, such that we will fine-tune the model and apply RAG and combine both. We don't have to select either one or two. We can combine both. And in practice, depend on the real situation, sometimes we can shut down the AAG and use the fine-tune. Or for some reason, we have to shut down the fine-tune and use RAG. That's okay, no problem. Or we can combine both. It will depend on the real situation in practice. And during the model development, we have to fine-tune, so we have to adjust model hyperparameter, such as the number of epoch for training the model, the number of batch, or the learning rate, the speed for updating the parameters. We also have to adjust. And for the search engine development, we have to select suitable method for search engine. For example, in the word-based, we have one popular method for word-based search is called BM25. Or in the vector-based, we also have many embedded vector. And I also mentioned that the quality of the vector-based depends on the length of the text. If the text is short, we should use the corresponding vector database for short. Vector model for short. And if the text is long, we can have corresponding embedded vector for long text. Those are maybe a GBT model or GLOVE or maybe a word to vect or any other vector machine. And in the search engine development, we can apply hybrid search with the re-ranking. In hybrid search, I mentioned that we will combine the result from various sources, and not all sources are equal. Some model are better than others. So we can adjust the weight to prioritize the better model rather than the worst model. So that thing will include in the hybrid search with re-ranking. And because we work with a vector, and our data set is huge, so they are likely that our database is very huge on vector. So it will make the time for calculating vector is enormous and huge. So we can apply some approximate retrieval solution, or we can apply indexing in our database for faster retrieval. And also, because we are working in LLM, so in the model development, we can apply prompt engineering, such as the chain of prompt. In ChatGPT, I implement the chain of prompt for detecting the language, rewriting the sentence, and a prompt for say sorry, prompt for generate the answer, the prompt for selecting the data. Is combined that it make a chain of prompt. Or we can make a React for suggestion. User suggestion, we can apply like knowledge base, apply React to evaluate the result and display the result to the customer. The last two module is the model development and model deployment and model management. In the model deployment, luckily we just only call the API. We don't need to worry about GPUs or GPU consumption. We don't care about that. We can call the model. The API right here, it might be API for fine-tune model, or the API for base model, or the API for both model. So in model deployment, we will call necessary and suitable API. Maybe we can do some fine-tune, like fine-tune one model for summarization, fine-tune one model for suggestion. And in practice, if user needs summarize, we call the summarize fine-tune model. If user needs suggestion, we call suggest model and take it out. And we can combine with RAG, depend on latency. I say the word depend on latency because in practice, for some reason, the search engine takes too long to retrieve the result. But our company need a low latency. So if that thing happen, we can drop the base model. We can use the fine-tune model instead. Just put to the input and ask to generate the output immediately. We don't need RAG anymore. Or we can combine like synchronous execution. You can imagine that we have two fine-tune models, one for summarize, one for suggestion. Given one input, we don't know if the user needs summarize or suggestion. So we can execute a synchronous approach, both summarize and suggestion, and the real client, the real person will check should approach we will use. And in the management model, that we will evaluate a system performance to check if the search engine work good or not, the fine-tune model generate hallucination or not, do they summarize the text correctly or not, and we can measure the latencies because sometimes the network is wrong, sometimes we have a loss of call from the outside. It's make our system collapse. So we also have to measure that. Or sometimes we have to detect the drift in model performance over time. What does that mean? It means that today people care about maybe iPhone X. So we receive a lot of data about iPhone X. And we fine-tune our model about iPhone X. But for some reason, people suddenly like kind of vintage, like iPhone 6 and iPhone 5. Then you suddenly receive lots of information about iPhone 6 and iPhone 5. So it will make a drift in model performance. Model performance suddenly worse over time. But if you check the search engine, you see, oh, nothing's wrong. You check the any other value, nothing's wrong. But the only wrong is that the data input now is start changing. It's come from the customer, not from us. So we have to detect the drift in model performance, and other time we can reevaluate our system and adjust our system. So you also mentioned that when we do the knowledge graph, should we build the entire graph by ourselves? Or the search engine, should we do anything from scratch? Luckily, I say that this is 21st century, so no, we don't need. We have lots of things to support. Because before I go to the some supportive, I need to mention that when we fine tune the model or data or configuration, it is better to backup. This is a thing we never forget. No backup. If some problem happen, then we will waste lots of time just to find the thing we already did. So it is better to backup fine tune model, fine tune the data, configuration, and also information we should backup. And for the third-party platform, there are many third-party platforms that can help us. Such as for the search engine, Kim Jin-wan suggests that we can use Elasticsearch. Elasticsearch is the software that they also implement the vector search and keyword search and the hybrid search. And I also mentioned that what happens if we have too many vector data, then we have to find the approximate solution. At that time, we can use FAISS, FAISS. The FAISS is come from Facebook. The F stands for Facebook. That they already implement a software, a platform for approximate solution. So instead of implement by ourselves, we can use their platform. For prompt engineering, there are also many platforms helping prompt engineering, including chain prompt, such as LangChain library or Llama Index library. So far, LangChain and Llama Index in the market right now is quite balancing. Many people like LangChain, but also many people like Llama Index. So in my point of view, instead of thinking which one to choose, maybe we can choose both. We don't need to choose either one or two, because they're both written in Python, so it's in help. For building the knowledge graph, we have two solutions. Number one, we can use the software called Neo4j. The Neo4j, they provide a function for adding the nodes, adding the edge, analyze the graph, finding the traversal graph, such as everything. But one big problem is that Neo4j, we have to pay the money for that. Yeah, that is a big problem. And if we want the free version, we can use the NetworkX library. The NetworkX is the Python library. And in my Kenya's SQL, I also use the NetworkX to build a graph. One disadvantage of NetworkX is that this is one disadvantage. In the graph, sometimes we have directed graph. Sometimes we have undirected graph. Sometimes we have mixed directed and undirected graph. But NetworkX cannot do the mix, just directed graph or not. So there is a case that I need to implement the graph that some node is the directed node, but some node is not directed. But the NetworkX don't allow that. I have to separate the process. For the embedded model, there are right now many embedded models available in the market, such as DeepSpeed, Hugging Face Transformer. Hugging Face, this is kind of the platform. There are many embedded models in that platform. We can utilize that. Jazz, using available library in PyTorch or available library in TensorFlow. For vector database, because we don't know the real vector database, so let's assume that we don't have. So if we don't have, we can use the vector database such as Pinecone, or right now in Dfocus GPT, we are using PostgreSQL. I never test about Pinecone, so I have no opinion, but PostgreSQL, me and Kim Jin-man test a lot, and it's quite useful. Also for programming language, because all of the LLM, they have many tutorials for Python. So usually we're using Python. But Bewontia Sansanim say that maybe sometime we should consider about Java for the latency. So all of this process also support in Java, such as ChatGPT also have Java calling, and prompt engineering, LangChain, I remember maybe they have Java or something, maybe I know. So it depends on the reality. We can choose either Python or Java or C++, anything else. Okay, so after 3 days, maybe, yeah.
Wow.
So after 3 days, many hours, yeah, finally done. The black link.
Very good. Well done.